right view of the binary tree. Suppose this is our tree, and if we are standing on the right side of the binary tree, what are all the nodes which are visible to us are 1, 3 and 4. So we just need to print those nodes, and this would be our answer. So for that, we need to do level or traversal and print the last node at each level. So we are going to do level or traversal and print the last node of each level. It is exactly same as the left view of the binary tree. And in left view of the binary tree, what we did was we printed the first node at every level. So let us see our approach and how we can code it. First, for storing our answer, we would be creating a vector, and for that we'll be creating a vector. And for doing level or traversal, we will be creating a queue, and that it would be of tree node star, because nodes would get pushed into it. And if someone is passing a null tree to you, then you just simply return answer, because you don't have to do anything. After that, you just push the root, and while our queue is not empty, we need to do level or traversal, and we need to print the last node at each level. We would be doing level or traversal. So tree node or temp to a temporary node is created to keep track of the nodes, if that particular node has a left child or right child. So suppose if queue size is equals to 1, we are at the first level. What we need to do is we need to store our temp in front, sorry, front element in temporary array, and just pop the queue. And after that, if uh, there exists child of that particular node, we just need to push into the queue. And if there exists right child for that particular temporary variable, we just need to push into the queue. After this, the temp would be at the last node of that particular level. We just need to push for that particular value in our answer, and I hope after we need to just return the answer. So this is the code. Let us first, before submitting, let us first try run our code. Suppose this was the sorry suppose this was the tree which I was talking about, is given to you as input. So in first case, what you are doing is creating a vector, answer vector. Let us create an answer vector to store our answers, and a queue, and this node is passed you as input. This is the root, the pointer to the root node is passed you as input. First condition check that if the tree is null or not. So it fails, so we come down, we just push the root in our queue, and currently queue is not equals to empty, so we go in this while loop and we calculate the size. Current size n equals to 1. So, and we create temporary node uh, temporary node pointer, sorry, temporary node pointer, and after that, while n minus minus, so it is post decrement. So we'll first use the value of n and then decrement the value of n. What we are going to do is in temp we are just going to put q dot front. Okay, so temp will be storing value 1, and we are just popping the q. Now q becomes empty, and we are checking if temp would be equal to this, and if temp has uh, left child or right child. Yes, it has, so just push it into the queue, and now our queue becomes this. But when we come after this 1 minus minus, since it was post decrement, the value becomes 0 and this condition fails, so we don't get into this while loop and we exit it. Again we check the outer while loop. Now q is not equals to empty, so we go in this while loop again and we calculate our value of n. Now n comes out to be 2, so again temporary variable is temp tree node is created, and here 2 minus minus is passed, is checked at while loop. So absolutely 2 is greater than 0, so we'll enter in this loop, while loop, and temp would be currently holding the value 2. After temp points to 2, you just pop it and decrement the value of 2. Now n becomes 1. Still 1 is greater than 0, so you will be in the same while loop, and you would be checking for if temp has left child or not. So temp does not have, temp is pointing to currently 2 and it does not have left child either as well as right child, so you just need to do not implement these two lines. And when n equals to 1, now temp would be pointing to 3, so now temp would be pointing to 3 and you just pop the elements, uh, pop the front element in the queue, and you check this. 3 has a left child, so you push it in the queue, and once you push into the queue, temp would be storing the now n becomes 1 minus minus, which is equals to 0. So this, at this level, at this point, this while condition fails. You will not enter in this loop. So after that, you push the value of temp in our answer. So first it get 1, and second time it gets 3. So now our queue has again queue is not empty, so you will go in this while loop again and you will calculate the size of the queue. Now it is 1, so you will enter this while loop. Now temp would be storing value 4. You just pop the queue and check whether 4 has left child or not. No, it do not have a left or right child either, so you just don't execute these two lines and just push the value of 4 in our answer, and this is our final answer, which should be returned to our function. I hope the approach is clear, so let us submit our code. It works. Actually, I have tried it 2 or 3 times before explaining you, so that I could explain better. It got accepted. So if you like this video, please hit the bell icon and subscribe to my channel. Thank you.